Welcome to the last video for section 1.4. We are going to continue talking about multiplying polynomials, and then we will also look at division by a monomial. So on this slide, we are going to multiply conjugates. Now, in the first video, we defined conjugates along with several other words. So you may have forgotten what conjugates are, but they are two binomials where the sign in the middle is opposite. So a plus b and a minus b are considered conjugates. Maybe you want to do x plus 3 and x minus 3. Those would be conjugates. You could do something like 2x minus 5y and 2x plus 5y. So it's just binomials where the sign in the middle is opposite. So you could FOIL to multiply conjugates, and that will always work. However, you can also take a shortcut, because look what happens. Let's go ahead and FOIL this a plus b times a minus b. If we did the whole FOIL process, we would do first a times a is a squared. And when we did the outside, it'd be positive times negative, so negative, and then ab. And inside is positive times positive, so you'd have a positive sign, but it's also ab. And then last would be positive times negative is negative, and b times b is b squared. So these two are like terms. When you combine them, this is a negative 1 and a positive 1. So negative 1 plus 1 is 0. 0 AB means it does not even need to be written. So all you'd have is your a squared term and your minus b squared. And that's what we're showing here. So it turns out that when they are conjugates, the outside and the inside will always be opposites and will always combine to be 0. So it is not necessary to even go through the work of doing outside and inside. You can just do first and last. So let's do a couple of examples. So number 1 here. And the only way you're going to know to do this shortcut is to recognize that they are conjugates. And they may be mixed in with, other multiplication problems that are not conjugates. So you really have to be paying attention. But if you notice it, the only difference between the two is the sign in the middle. So that tells me I can use my shortcut and just do first and last. So if I do first, I do n times n is n squared. And I do last, a negative 4 times a positive 4 is negative 16, then that's it. I'm done. If we had done outside and inside, let me just show you real quick. Outside would have been plus 4n, inside would have been minus 4n, and that's 0. So you wouldn't have had an n term in your answer. Number 2. Also, conjugates. They're exactly the same except for the sign in the middle. So let's do first and last again. If I do first, 5a times 5a is going to be 25a squared. And last, positive 3b, negative 3b is a negative 9b squared. And that's it. I don't have to worry about outside and inside because they, again, would just equal 0. Okay, so nice shortcut to use for conjugates. Next, let's talk about squaring a binomial. When we learned our exponent rules in 1.3, we had a rule that said a times b to the n equals a to the n times b to the n. And then a lot of students want to apply that rule when you have a binomial, when you have two separate terms. And remember, ab is just one term because that's multiplication. But now we have addition in here. We've got two terms. You cannot just put that exponent on each term. It does not work. You can only do it when these are multiplied, not when they're added or subtracted. So if I want to find a plus b squared, I have to actually square it, which means to multiply it times itself. Just like if I want 5 squared, I have to do 5 times 5. Well, here I have to do a plus b times a plus b. And there's no shortcut. You have to FOIL that all the way out. The only time you can skip outside and inside is if these signs are opposite, but they are not opposite. They're the same. So you FOIL. And you'll end up getting a term in the middle that you would not get if you just did a squared plus b squared. In fact, let's go ahead and FOIL that out. First would be a squared. Outside would be ab. Inside would be ab. And last would be b squared. So when you combine those terms in the middle, 1ab plus 1ab is 2ab. And that is what you would get. That's the correct answer. If I just square a and square b and wrote a squared plus b squared, that would not be correct. It's missing that middle term. So let's practice. 7x minus 2 squared. So the first thing you're going to do on these is write it out twice. To square it means to multiply it times itself. And then FOIL. FOIL it all the way out. So first, 7x times 7x is 49x squared. Outside, 7x times a negative 2 would be a negative 14x. Inside, negative 2 times 7x is the same. And actually, whenever you start out with a binomial squared, when you do the outside and inside, they will always be the same. Last, negative 2 times negative 2 is positive 4. Combine your like terms. Negative 14 and negative 14, same signs, add and keep the sign. And it stays x because we're adding. And we still have our plus 4. And there's our answer. Notice it is not the same answer that we would get if we tried to just square the 7x and square the 2. Has to be done this way. So go ahead and try number 2 on your own. So the first thing you do, write it out twice. And next, FOIL. First, 3x times 3x, 9x squared. Outside, 3x times 8y, both positive, everything's positive in this problem, is going to be a 24xy. Remember, variables alphabetical. Inside is also a 24xy. And last, should have written a little bit smaller here. Let me just go ahead and make that where we can fit it better. So first, 9x squared. Outside, 24xy. Inside, 24xy. And last, 8 times 8, 64. Y times y, y squared. The terms in the middle are like, so we're going to combine those to be 48xy. And that's our answer. And it is in standard form. Remember, when there's more than one variable, standard form is alphabetical, x term first, y term last, term with both variables in the middle. So that is how you square a binomial. Okay, last topic for this section. Dividing a polynomial by a monomial. So this could have any number of terms, but this, remember, only has one term. So when you have just one term as your divisor, so let's say it's an x, and you have a plus b plus c. Could be any number of terms on top. Remember, the fraction bar is your division. All you have to do is divide each term on top by the term that's on the bottom. So you can do a divided by x plus b divided by x plus c divided by x. And sometimes those can simplify and sometimes they can't. Okay, but that's the process. Now, let's just say for a second I had a plus b plus x divided by x. A common mistake is that students want to try to cancel out those x's, and you cannot do that and then say, okay, now that's equal to a plus b. It is not. You can only cancel over multiplication, and since this is addition right here, you are not allowed to cancel those x's. So you have to divide every term on top by the term on bottom. That's the only way to do it. No canceling. So let's see some examples. And I'm going to go ahead and write it all out. So on number 1, I'm going to take each term on top and put it over 5n squared. Keep your minus sign here between, and then this one's going to be a plus sign. And then you're ready to simplify each of those. And that goes back to our lesson on exponent rules. We had some problems just like this right here that we had to simplify. So you start with the numbers, and we can do 10 divided by 5, which is 2. I want you to go and write it as 2 rather than 2 over 1. And then we do our variables. And the exponent rule says when you're dividing, you subtract the exponents. You keep the same base and subtract top minus bottom. So it's 4 minus 2 and makes that n squared. Then you need your minus sign. 20 divided by 5 is 4. And again, here you keep the n and do 3 minus 2. 3 minus 2 is 1. Since it's a 1, we don't have to write it. And on this third fraction, the numerator is exactly the same as the denominator. And when that happens, that fraction is equal to 1. Anytime the top and the bottom are exactly the same, you get 1. Now, maybe you thought about it as 5 divided by 5 is 1. And then you said, okay, for n, I need to do 2 minus 2. You could do that. It'd be n to the 0. But there's another exponent rule. N to the 0 is 1. So now that'd just be 1 times 1, which is back to regular 1. And so all we want to put there is just 1. And there's our answer. Now it turns out that we ended up with an answer that didn't have any fractions in it. Sometimes that happens, but a lot of times you will have fractions in your answer. Okay, so number 2, I may need a little more room than what I have, so I'm going to come back over here and erase a little bit to give myself some more room. Okay, so each term on top divided by each term, or by the only term on the bottom. Let's write it out first. Don't start canceling anything, just write everything out. And then we'll go through and simplify each of these fractions. So we look at the numbers first. This is an invisible 1 here, so we've got a 1 over 4. That cannot simplify. Now the variables. When you have division with variables. It's the top exponent minus the bottom. So if I had x squared over x cubed, which is what I have here, the rule says to do 2 minus 3 as the exponent, and that would make a -1. And you could write x to the -1, but then you'd have to go to another step and say, okay, I need that to be a positive exponent, so I need to move that down to the bottom. And that will work every time. However, here's a shortcut. If you just look at the variable that's the same and put the variable where the bigger exponent is, then you don't have to go through the negative exponent. All right, so let's come back here. I've got that 4 on the bottom. That's not going to move. But for the x's, my bigger exponent's on bottom, so I'm just going to keep the x on the bottom, and as long as I do that, I can just do the big minus the small exponent. So I can do 3 minus 2, and that'll just be x to the first power. And I just realized that I told you all of that, which wasn't exactly necessary yet, because I did not write the correct exponent here. I apologize for that. Let me fix that. That was actually an x to the 4th here that I miscopied. Okay, so again, I'm still going to have that 4 on the bottom. But now for both x and y, my bigger exponent's on top. So I just keep the variable on the top and do 4 minus 3, so it'll just be 1x. And for the y, it's 4 minus 1, so it'll be y cubed. So xy cubed, I'm going to put that closer, xy cubed over 4. Plus, okay, second fraction here, I'm going to do 8 divided by 4. And since that goes evenly, 4 goes evenly into 8, I'm just going to make it 2. I don't have to have a fraction. But now I end up with the situation I was showing you over here, where I have a bigger exponent on the bottom. So I'm just going to keep that x on the bottom and do 3 minus 2, so it'd just be a single x on bottom. Now for y, because the bigger one's on top, I'm going to put y on top, and it'll be 2 minus 1, so just a single y on the top. So again, that's the shortcut, putting the variable where the bigger exponent is, but you could have also gone through all of this right here to end up with that x on the bottom. Look at the last one. We've got 4 divided by 4, which is just 1. And we've got a y divided by a y, which is just 1. So really, all we need to work on are these x's. And we've got a bigger x on bottom, so we're going to keep the x on the bottom and do 3 minus 1, so it'll be an x squared. Now you do have to have something in the numerator. So with that 1 that you get when you do 4 divided by 4 is going to go in the numerator. And that is how we would write the answer. So really have to know your exponent rules well to simplify those fractions. If you have any questions, feel free to email me, or you can ask during class. And be sure and work all the homework problems to get lots of practice.